Hi, I'm Dr. Christopher Sutton. Welcome to my Introduction to GIS video series. In this video, we are going to cover Earth coordinate geometry. You may already be familiar with latitude and longitude, but I want to make sure that we're all on the same page with how Earth coordinate geometry works. So if you already understand these concepts, please bear with me. This foundation is important for everyone. At the end of the previous video, I mentioned that there is a grid covering Earth's surface known as the graticule. This graticule is what we use to determine coordinate positions on Earth's surface. You may recall from an earlier video that Earth has two fixed points where the planet's axis of rotation intersects the surface, the geographic North Pole and the geographic South Pole. The first reference line in the graticule is the equator, located halfway between the geographic poles. The equator circumscribes the planet, and from it we measure latitude. Latitudes are circles around the planet that run parallel to the equator, which is why you often hear latitude lines called parallels. These lines of latitude mark position between the equator and the poles. But how exactly do we define that position in a geographic coordinate system? Coordinate position is measured in degrees of arc. For latitude, a location's position is defined as the angle from that location to the equator. Let me give you a conceptual example that helps visualize this angular measurement. In this image, imagine you're standing at the location identified in yellow. If you draw a line from that position to Earth's center and then another line out to the equator, you can see that the angle created is 30 degrees. Therefore, the coordinate position is 30 degrees. Because that position is north of the equator, we specify it as 30 degrees north. Now, this is not how people actually calculate latitude in practice, but it's an example that really helps my students grasp the concept. Latitude values range from 0 at the equator to 90 degrees at the poles. So the coordinate positions of the geographic poles are 90 degrees north and 90 degrees south. Now let's look at the lines perpendicular to latitude in the graticule. These are called longitudes or meridians. Unlike latitude lines don't circle the planet. Instead, they're drawn from pole to pole without continuing around the planet back to their starting point. The meridian from which the coordinate positions are measured is called the prime meridian, which has a longitude value of 0 degrees. Let's use a similar example to what we saw with latitude. Again, imagine you're standing at the location identified in yellow. Draw a line from that position to Earth's center and then another line out to the prime meridian. You can see that the angle created is 30 degrees, giving us a coordinate position of 30 degrees. Because this location is west of the prime meridian, we can specify the position as 30 degrees west. Because individual longitude lines don't encircle the planet, there are actually twice as many longitude lines as latitude lines. Longitude values range from 0 degrees at the prime meridian to 180 degrees at the meridian directly opposite it. The complete graticule looks like this. The origin of the graticule, the 0, position, is located at the intersection of the prime meridian and the equator. This point sits in the Atlantic Ocean in the Gulf of Guinea off the west coast of Africa. Now here's something interesting about the graticule. While the equator is based on Earth's geometry, it is located exactly halfway between the geographic poles. There are no such geometric features to fix the location of the prime meridian. So why is the prime meridian where it is? We will discuss that in the next video.